Okay, we are going to start with the notes for combinations of functions. This is near the back of your packet. It's very short, where this one is we're basically taking 2 or 3 or 4 functions and we're combining them using adding, subtracting, multiplying, and dividing. So this slide right here shows you, and you can see I've got part of it circled, that you could have the adding of the functions. So if I had 2 functions, f of x and g of x, that I could add them by doing this, subtract by showing the subtraction, multiplication, it's understood that it's there, and here's division. You could also see it over here on this side, basically, where you've got where they do f plus g of x, f minus g of x. They mean the same thing, fg of x and f divided by g of x. So this left is the same as the right. I just wanted you to be sure that you saw this and realize they're both the same. I typically use what's in the circle, but there are textbooks, and when you go to college, I don't know what your professor would prefer, but at least I wanted you to see it. So I'm going to do a couple pages of practice. So I have these 2 functions, f of x and g of x. So basically, I'm going to add them in that order, subtract them in that order, divide them in that order, and multiply them in that order. Because you can switch them any way you want, but that's how I'm going to do the notes. So the first one is when I add, is I'm basically saying x plus 1 over x. And there is the combination of those 2 functions. However, in this course, I want to make sure that you can, instead of having 2 terms, that you're able to do the algebra to give me 1 term. So I realize that this is over 1, so I have to have a common denominator of x. And you'll see that this fraction stays the same. My smart 1 is going to be x over x, so it's x squared on the top there. So I'll erase this 1 here so it doesn't get you confused. So it's x squared plus 1. And because now my denominators match, I can say they're in love. I can combine them. So the answer for that one, or the single term, would be x squared plus 1 all over x. And so that is the addition of those 2 functions. And I look at it to see if I can factor it to simplify, and that's not the difference of 2 perfect squares, but the sum. So I can't touch that, so that's my answer. My second one is I'm actually going to subtract those 2. And this kind of goes along the same line. So I know that's over a 1. So my common denominator is going to be x. This fraction can stay the same. My smart 1 is going to be x over x. So this is going to be x squared. I can say, okay, they have a common denominator. They're in love. Now I can combine them to x squared minus 1 all over x, which is your answer. Or you can recognize that that's the difference of 2 perfect squares, which is x plus 1 times x minus 1 all over x. I would give full credit for both. I kind of like the second one a lot because it shows me that you try to factor to simplify. So either one of these would be accepted and you'd get full credit. The division, okay, so I have, well, let's do the multiplication first. So the multiplication, I have x times 1 over x, and there's a couple ways you can look at this. You can put this over 1, multiply across the top, multiply across the bottom, you'd get x over x, or the answer is 1. The other way you could do this is to recognize that these can divide to make a 1 right off the bat, so you can get a 1 that way as well. So the answer to that one is 1. When I divide them, I have x divided by 1 over x, and you can write it like this. And then I recognize that that is a complex fraction, and my denominator that I'm going to multiply by the numerator and denominator is x. So I have an x squared in the numerator, and the denominator, they cancel out to make a 1, so it's just x squared. The other way you can look at that is saying I have x divided by 1 over x. So if I'm dividing by 1 over x, that's the same thing as saying x times the reciprocal, which again is x squared. So either way works. I just kind of think it's simpler to use the complex fraction, and to do that, you can quickly come to a better way of writing that instead of having a fraction within a fraction. And the last slide we're going to do is to practice this yet again. We're going to start with these two different functions, add, subtract, multiply, and divide, in the order that they're listed. So the first one is I'm going to add f of x and g of x. So it's x squared plus 1 plus x minus 3. Now the one thing I do want you to notice, by me adding them, this is important that you look at that, is because I'm adding them and it's a binomial, I'm not too worried about the sign changing because I'm just adding. So then I basically combine like terms and put it in the powers in descending order like we're used to seeing it. So the answer would be x squared plus x minus 2. I combine the 1 and negative 3. So there is that added. When I subtract x squared minus x minus 3, this is again, I'm subtracting. When I subtract, I definitely need to have that because I look at this minus sign. It's like a negative of 1 in front of there. You're going to have to distribute that negative sign, which will change all the signs of those terms. So you'll have x squared plus 1 minus x plus 3, and then go ahead and combine and put your exponents in descending order. So I have x squared minus x plus 4. So this is what it would be subtracted, and the one above is what it would be added. Now, if I'm multiplying, I would do x squared plus 1 times x minus 3. So I'm multiplying two binomials, so I'm going to double distribute. So I'm going to multiply x squared times the x, and then x squared times the negative 3. So I have x cubed minus 3x squared. Now I'm going to do the 1, the positive 1. So I'll be plus 1x, or x, minus 3. And guess what? There's nothing you can do with that, and it's nice and neat in order. That is that multiplied. And then last but not least, I'm going to divide those two. So I have x squared plus 1, and I'm dividing x minus 3, and I could leave the parentheses there or not, but there's really nothing you can do. You can't factor the numerator because that's the sum of two perfect squares. So my answer is just the way it is. I cannot factor the numerator, can't touch that, that's MC hammer, and x minus 3, so that's what that is. Okay? Now you are going to have to do a combination of functions lab. So what I want to do is I'm going to clear the ink from this. Edit, clear the ink from this page. And I want to do number 13 with you on the combination of functions lab that goes along with this, okay? So again, I have f of x equals 1 over x plus 1. It says find and simplify f of 1 over x plus 1 over f of x. So the pre-calc part is basically, can I figure out what they want us to do, set that up, and then simplify into a single term, okay? So the first one says I'm going to do f of 1 over x. So that's going to go right in that spot right there. So when I do that first one, it's 1 over x plus 1. I know it's ugly. Then they want us to add, okay? Then they want us to do 1 over f of x. So there's my 1. My f of x is this entire function. That whole thing is going to go down there, okay? So I'm going to do that. 1 over x plus 1. Now I know it's ugly, okay? So I got to combine these. So the first thing I'm going to do is this is a complex fraction, multiply everything by the common denominator. So that comes out to be x over, this divides to make a 1, plus nothing cancels there as well. So that changes to that nice fraction there. Plus, again, this is complex. My common denominator is x plus 1. Multiply by that. It really divides out to make a 1 in the denominator. So the whole thing is 1 times x plus 1, or x plus 1. Which is nice, but still it's not simplified enough. So I realize this is over a 1, and I want to find a common denominator. Now I write big here, so you should have enough room. But I'm going to switch this order and call this x plus 1, and I'm going to add, that's my denominator. So this first fraction here remains the same because all I did was just switch their order, and that is that fraction. Over here on the right, I see that my denominator is 1, so I have to multiply the numerator and denominator by my smart 1, I call it. And when I multiply that out, it's binomial times a binomial. I have x squared plus 2x plus 1. X squared plus 1x plus 1x plus 1. Now my denominator is the same. They're in love. I can combine the numerator. So I end up with x squared plus 3x plus 1 all over x plus 1. And I would suggest on something like this that you do it again and make sure that you understand how you went from plugging into what they want here all the way to taking it, simplifying it, find a common denominator, combine the numerators to come up with that. So there we go. There is combination of functions. And I need to have you finish this lab all the way up to 21, where you're practicing putting functions together in compositions.